Hi guys, Mr. Bennett here again. Looking at exercise 2G4, what we want to do is look at finding the tangents so we can find the rate of change of a particular value. So just want to do a couple of quick examples for you. For these two graphs here, and I'll print the graphs off for you so you can actually do them on the actual graph itself. Now, when we're doing this, what you want to do is you want to draw a line that obviously is a tangent, that point there that goes through. You want to draw it so at least goes through a point. Okay, so and you sort of fudge it a bit so you make sure it goes through a nice point for you so you can identify that. So if I was going to identify this point over here, that would be 4, 5, isn't it? Alright, we have this point over here, which is the other point on our particular graph. Now that point there is in fact 1, 2. Now if I want to find the slope of that line, which is really what it's asking you to do, it's a rise over run. And so therefore what we'd be looking at is the change in the y values over the change in the x values. So I'm going to say that's going to be equal to 5 take 2 all over 4 take 1. So it's going to give me an answer of 3 over 3, which has got a slope of 1. Now don't forget to put your units on here. The distance that we're looking at using the change in the y is m, and then the time is meters per second. So therefore that there has a instantaneous rate of change of 1 meters per second at that particular point when t is equal to 1. Right? Doing the similar sort of thing over here. I want to go through that point there, and I've sort of fudged it a little bit so it looks like it goes through this point up here, and it goes through that point there. Now it's not obviously exact at 3, so it might be 3 point. So that point there might be 3, and then 4 point, now maybe 4.4 or something like that. And this point over here might be, say, 5 and maybe 10. So that's okay. So again, finding the slope, that's going to be 10 take 4.4 all over 5 take 3, so that's going to give you 5.6 all over 2, which is equal to 2.8, and then the distance is kilometres per hour. Okay, so gives you a bit of an idea about the sort of things that you're doing there. Now obviously what we're doing in these cases, we're going through the process of drawing a tangent line to the curve that goes at that point, keeping in mind that we can try and match it so it goes through a grid point. You know, try and match it so it goes through one of these lines if you can, and then you can actually work out what the tangent might be at that particular point by using the equation of the slope. So good luck with those questions. They're not that hard, I don't think. I think you guys will cope with those quite well. But there's 2 examples for you, and finish them off for us. Thank you. See ya.